Hey, discrete math students, and welcome to this extra example video on analyzing form of sentences. So, if I've already mentioned this, I'm happy to harp on it again. Symbolic logic really is its own language. And when we want to go to convert from natural language to symbolic logic or vice versa, we are doing a language translation. Now, language translation has a lot of aspects of an art to it, not just purely science. It's not just a one-to-one correspondence of you take this word, you turn it into that word, and so on. There's context to take into account, a lot of subtle aspects. Some of those include the way that structures are represented differently in different languages, and perhaps most important of all, what is the meaning that is intended here? And we want to make sure that we are faithfully representing that meaning. Sometimes it is a little counterintuitive to what at first may seem obvious. So let's see if we can do a couple examples of that here, going in the direction of translating from natural language to symbolic form. So the first step in any application of symbolic logic, if you've got a natural language situation that you want to apply symbolic logic to, is you got to convert it. You got to translate it into symbolic logic in order to get started. So you got to put everything in terms of symbols, and that has an official term to it. It's called analyzing the form of that natural language situation. Okay, now certainly our textbook has a number of examples of this. The excerpt from How to Prove It that I provided as an additional resource, that has some more examples as well. But the more the better with something like this, because of all the different aspects to it. So let's do a couple more examples on this video now. Okay, so here are some sentences where we want to analyze the form. Again, that means we want to convert into symbols. Well, of course, faithfully representing the meaning of the original sentence. So first we've got, if Sebastian finishes his bread or his carrots, then he can play on the computer. Okay, a very common sentence that might have been spoken in our house, 10 years ago or so. Okay, so to analyze this, part of what's going to be involved will be our logic variables, and those represent the simple sentences within this compound sentence here, and we need to define those. We need to be clear about what's our dictionary here in terms of translating between these two languages. So you look for the simple sentences in here. How many do you see? Well, you can pause and think about it if you want. There are three simple sentences, and so let's lay out some variables for them. So Sebastian finishes his bread. I think that's one of our simple sentences. And again, I'm somewhat of an advocate for choosing your variable to kind of represent what the natural language sentence said, even though, of course, we are sort of purifying ourselves from the context on some level. It may be good to remember where these variables came from. So I'm going to say let B represent Sebastian finishes his bread. Oh. Okay. Now, we also have another sentence here. All the sentences actually involve Sebastian, right? Even the third sentence where it says he, that he, of course, refers back to Sebastian as well. Another simple sentence involved here is Sebastian finishes his carrots. So let's use C, kind of hearkening our thoughts to carrots, perhaps. Let's C represent Sebastian finishes his carrots. And one more simple sentence to go here.
and that would be Sebastian can play on the computer. Now, we can't let C represent that. That would be conflict of notation. We can't double use C, and so here I'm going to use P for play. Let's let P represent Sebastian can play on the computer. Okay. All right, now let's take a look at how this is going to translate. We've got our logic variables for the simple sentences. There are also some connectives involved here. We see an if-then. That's a conditional implication, so we'll have our right-facing arrow for that. And we also have a or here, and in this case, or is, it does seem like disjunction is the right way to interpret that. And in particular, you got inclusive, exclusive. We've talked about one like this before. Sebastian would not be very happy if we made this an exclusive disjunction and finished everything. So certainly the sense meant here is inclusive. So Sebastian finishes his bread, or Sebastian finishes his carrots. Let me move this over a little bit, actually, because what this is it's our symbolic form. So we've got B, Sebastian finishes his bread, or we want to have our inclusive or here, so we'll put the wedge symbol there. Or Sebastian finishes his carrots, that's C. And then we have this if-then, so the part that's being implied here is this end part. Sebastian can play on the computer. We want to represent that with P. Okay, so we've got all the major elements here in terms of both simple sentences and connectives. But as is, this symbolic formula is lacking something very important, and that is an indication of precedence here. We've got two different connectives, and we need to know what is the main connective, what's applied first and what's applied last. Well, looking at the nature of the sentence here, we can really see that it is clearly divided into two main parts overall. And one of the things that tips us off to that is the comma. Commas are often used to signify a major division in a sentence. So the first main part of this sentence is if Sebastian finishes his bread or his carrots. And then we want that entire part to conditionally imply the part that's after the comma. He can play on the computer. And so how do we make that happen? How do we make the disjunction here take precedence? Well, we do that with parentheses. Okay, so now it is very clear that it is the compound formula B or C that is implying P. So the parentheses here take the place of the role played by the comma in the natural language. Very important to recognize these different things in natural language that can kind of play that role. If you did not have the comma, okay, it would still be very safe to presume that's how the symbol should be grouped. Because if Sebastian finishes his bread or his carrots, right there, you're already seeing those two simple sentences being really kind of melded together in a way that indicates they're to be thought of as a unit there in the front part of the conditional implication. Okay, so there's one example. Let's see. Yeah, again, so we use parentheses very strategically and importantly in our symbolic forms. There's a sentence we already did. Okay, for our next sentence, let's take a look at this interesting one. An integer is both prime and even if and only if it's 2. Okay, I wonder how many simple sentences are involved here. Again, you can think about that. And also consider, is this a statement we're dealing with here? I think that's an interesting question. Probably you could say that it is a statement overall. But the components, the pieces that this that sentence is made up of. Individually, they are actually not statements, but they are predicates. Okay, there's a variable in here. Now we don't see a variable, which is actually one of the important things that we're going to need to draw out when we convert to symbolic form. So here I'm talking about a mathematical variable. Certainly we'll also have some logic variables involved. So let me see how much space I left myself on this. Okay, quite a bit. Okay, so we're going to have a math variable involved, and I'll just put up here that n represents, well, let's put it this way. N is a variable with domain. I wonder what it should be. Well, we know we're talking about an integer here. Okay, and so we need to have the z. Z represents a set of integers. That's the right domain for our variable. Again, very important to introduce that for symbolic form purposes, even though we don't see the variable appearing in the natural language sentence. We know really it needs to be there, and it is there behind the scene. Okay, so now let's assign variables to our simple sentences. And again, here we'll use the predicate notation for those because of the fact that these are indeed going to be predicates. So one simple sentence that's involved here is n is prime. Okay, n is prime. That's simple. Certainly can't reduce it any further. We get that out of the kind of the front half of our sentence here. So prime, let's use p of n to represent that. Let's let p of n represent n is prime. Okay, now we've got a clear assertion, even though it's not a statement, because n has not been bound here, but it is a convenient and sensible way to reframe that simple sentence. Another simple sentence involved, n is even. Okay, an integer n is even. Well, our integer we're calling n, so let's let e of n represent n is even. Okay, now the simple sentence at the end may be a little trickier to hash out what that's saying. Okay, if and only if it's 2. It's 2. Well, it, of course, is referring back to the same integer that we have been talking about, which we are calling n. So the non-awkward way to say this sentence, and let's see. Let's use t of n for this. T here I'm thinking of as standing for 2. Let t of n represent n is 2. Now you could say n equals 2. Okay, just for fun, let's do it that way. N equals 2. Okay, so there are our 3 simple sentences. And now we're ready to analyze the form. So symbolic form for this one. Okay, so we've got an integer is both prime and even. Well, you see there, that's a pretty blatant conjunction here in the first half of our sentence. We are requiring 2 things of our integer. So in symbolic form, we would want to use conjunction for that. Both of these things are being asserted to be true in that first half. P of n and E of n. We would read that. Okay, and if and only if, that is our perhaps our last connective from our original list. That's if and only if. That is a biconditional implication. Biconditional implication is the double arrow pointing both directions, indicating that each of these implies the other. Kind of a messy if and only if there. Hopefully it's clear enough. If and only if it's 2. So that's our t of n. N equals 2. Well, same issue as before. We want to indicate the precedence here, and we don't have a comma to help us out this time. But we do have a key signal word that indicates where our conjunction should begin. Okay, and that is the word both. So an integer is both prime and even. So the way that sentence is set up, both prime and even, that really tells us, again, we're requiring 2 things of our integer. These should be grouped together. So we'll put parentheses around P of n and E of n. Again, besides commas, these kinds of words, both, either, and so forth, very key in interpreting the meaning in terms of precedence in which connectives are applied. So we'll put parentheses there, and then it's if and only if, T of n. Okay, so again, the whole first piece is what's meant to be true if and only if T of n, which is n is equal to 2. So there's the symbolic form for the second one. So again, one of the key takeaways here, I think, is in symbolic form, it's not just logic variables and connective symbols. Also, another very key part is that we use parentheses to avoid ambiguity about which statements are combined first, which connectives are applied first. Just like there are indicators in natural language about that, we have that in symbolic logic too, and it's parentheses. Now, what if there aren't parentheses? How do you know what to do first? Well, just like in algebra, you have sort of this order of operations for your arithmetic, your arithmetic operations. Supposedly, there is one like that for symbolic logic as well, but my recommendation is you don't rely too much on that. Really, we want to use parentheses, and you should use parentheses to make sure you're really clear about, okay, what operation should take precedence here. Now, there is one convention that is universally pretty much followed, I believe, and we will follow it as well. And that's when you have a negation. It only applies to the component immediately after it. All right, so whatever comes right after it is the only thing the negation applies to. Now, just like with any order of operations rule, you can override it with parentheses. So if the negation is followed by parentheses, then it's going to apply to whatever's in those parentheses. So that's one thing we don't have to worry about using parentheses to do, is say that a negation gets done first. That is an automatic. So again, you got this whole order of operations about what takes precedence over what, but I'm not going to dwell on that whatsoever and say that you should really use parentheses just to make sure your meaning is crystal clear, whether you're talking to someone who's aware of that order of operations or not. Okay, just a couple of concluding comments here. Again, reverse direction, converting from symbolic form to natural language. We'll look at some of that in class. I think the big moral here is that you gotta be careful when you are translating to or from symbolic logic, because again, we have these signal words we look for, but it's not always that clear cut. Okay, we like to think of our conjunction symbol, maybe disjunction, negation. We like to think, conjunction, that's and, disjunction, that's or, negation is not, and so forth. But that's not the whole story, right? For instance, just because you see a word and, that sends up the flag for, conjunction, but not necessarily. We take a look at a sentence like this, and there are lots of sentences like that out there. 15 and 28 have only one divisor in common. All right, well, you say, I can split that up. But what would the split up be? 15 has only one divisor in common? In common with what? That doesn't make sense. You need two numbers to talk about their common divisors. So this sentence actually cannot be broken down any further, which means it is a simple sentence. And by definition, that says it has no connectives. So the and in this sentence is not a connective because it's not being used to combine two simpler sentences. There are no simpler sentences here. So definitely be on the lookout for that. Lots of uses of these signal words that are, where they're not connectives in those contexts. Okay, it doesn't combine two statements, and that's what a connective and needs to be doing. We've already seen one like this, so I won't dwell on it. The shelter is cold but dry. Okay, we could reword it into something like the shelter is cold and the shelter is dry to really draw out there that this one is in fact a conjunction, even though it doesn't have the word and that's going the other direction with this correspondence being kind of imperfect, you might say, is that other words can be used for a conjunction. Okay, just like the word and does not always represent a conjunction. Okay, now how about this one? Oh, you gotta love ones like this. Rain and snow are the two possibilities for tomorrow's weather. Say the weather forecaster said that. Is the weather forecaster using a conjunction there? Pause and think about it if you want. Okay, actually here, I think if we were gonna do something like the following and say let R represent it will rain tomorrow. And if we let S represent it will snow tomorrow, what kind of connective is between those? I don't know about you, but I see a disjunction there. What's this really saying? In plain, simple wording, logical kind of form, it will rain tomorrow or it will snow tomorrow is basically what it's saying. And you could maybe get a conjunction there as well, something like, and there are no other possibilities for what kind of weather we'll have tomorrow or something like that. But I think the basic meaning of it is a disjunction, even though it uses the word and. So again, just because you see an and doesn't mean automatically, oh, that's conjunction. It could be not a connective at all. It could be a different connective. I thought of one more example. Okay, now tell me if you've thought something or written something like this. The answer is 0.6 or 3/5. Okay. If you say something like that, what are you saying? Are you saying, well, it's one or the other, could be both, or maybe it can't be both? That'd be really bad. You're actually, I would claim, not using a disjunction there. Right? That is what you're really saying there is the answer is 0.6, or that is equivalently the answer is 3/5. So equivalently there, you're really using a if and only if. That is a biconditional implication. But what word did you put? Or, right? And it's used like that a lot. And there are many examples of this kind of thing. Okay, so I hope in this brief excursion here, you do kind of get this really important idea across that you cannot just look for keywords and go on autopilot with this. Many times you really need to think carefully about what's going on and not just what words the sentence has, but what does this mean? What is the meaning intended here? And translate faithfully according to that meaning above all else. All right. Hope you enjoyed this extra example video, and we'll see you again soon.